In this video, I will show you how to create a Neo4j Cypher chain which uses two LLMs. The first one is used to convert the user query to a Cypher query, and the second LLM takes the Cypher query results and translates them to an answer given to the user. As a reminder, this is the architecture of our hospital system chatbot, which uses an agent to answer a user query. This agent has three tools available in our case, which are the wait times function, the Cypher chain, and the reviews vector chain. But in this video, we will focus only on the Cypher chain. So now let's look at our Cypher chain. So as you see here, it's an instance of the graph Cypher QA chain. In this chain, we pass two LLMs, the Cypher LLM and the QA LLM, because as I mentioned, we need two LLMs. The first one to generate the Cypher queries based on the user question, and the second one is to generate an answer to the user given the Cypher query result. And for the models, I'm performing API calls through Hugging Face. I precise the model here that I define in my environment file. As you see here, I precise two different environment variables, but in my env file, I actually call the same model. So it's a good practice here, so that if we want to use two different models, it's possible to just change the model in the environment file. Here it's a .env.example file, but you need to copy paste this information and to include it in your .env file. Once you passed your LLMs, you need to pass the graph, which is a Neo4j object that connects to your Neo4j instance that we created in the previous video. We set verbose to true. It means that we ask to print intermediate steps that the chain performs. We pass the QA generation prompt that will be given to the QA LLM. We pass the Cypher generation prompt that will be given to the Cypher LLM. We will see, guys, how we define these prompts and even the graph in not long. We set the validate Cypher to true. In this case, the Cypher query will be inspected for errors and corrected before running, but this only inspects syntax errors using regular expressions, but doesn't guarantee that the Cypher query is valid. We set the top K to 100, which is the number of query results to include in the QA prompt. And last but not least, we have to set the allow dangerous requests to true. This is actually a security flag where the user acknowledges and accepts the risks of executing LLM-generated Cypher queries. Now let's look at our different prompts. Let's start with the QA-generated prompt. The QA-generated prompt is actually a prompt template, and if you are not familiar with prompt templates, guys, I invite you to watch the first videos of this series where I explain the difference between using prompt templates and not. So in our case, our prompt template has two variables as placeholders. We have the question variable, which is the user question, and we have the context, which is the result of the Cypher query execution. So at this step, the model will take the user question, will take the result of the Cypher query execution, and will answer to the question based on this context. And this is what we precise in the QA generation template. We tell the model that it is an assistant that takes the results from the Neo4j Cypher query and performs a human-readable response. We add some additional information to the model, such as the query results section contains the results of a Cypher query that was generated based on a user natural language question. We ask the model to never doubt this information and never use the internal knowledge. So here it's to avoid hallucination, where the model doesn't base itself on the given context and tries to answer to the question differently. Once we have these instructions, we pass the context here, we pass the user question here, and we add additional instructions to guide the model to provide an acceptable answer. So as you see here, we tell the model that if the provided information is empty, just say that you don't know, so don't invent new information. If it's not empty, base yourself on the results to give the answer. Some instructions on hospital names, like here when there is a comma, we explain that it's only one name and they are not many, and so on. So here you can update the prompt by adding other instructions if needed. And what you can do, guys, is you can just remove some instructions or add more and see how the model behaves based on that. So this is for the QA generation prompt. Let's look at the Cypher generated prompt now. Here we are using a prompt template as well, where we have two variables, the question as usual, which is the user question, and the schema variable to show the model our graph structure. Now let's look at the prompt. We start with defining the task, which is generating a Cypher query for a Neo4j graph database. We ask the model to use only the provided relationships, types, and properties in the schema, and not to use any other relationship types or properties. This is very important to try to avoid hallucinations. We pass the schema to the model and we add some more notes to guide the model in generating the answer. For example, we ask the model not to include any explanations or apologies in the response. The model doesn't have to respond to any questions that are unrelated to construct a Cypher statement. It needs to take into consideration the direction of the relationship. It has to pay attention to alias, not to run queries to add or delete information, and so on. And here we provide the model with examples, and this is what we call few-shot learning, where we provide the model with examples in the prompt so that the model learns from these examples. So here we provide an example of the user question and its associated Cypher query. Here is another example with its Cypher query, and so on. So here in total we provide 4 examples, but depending on your model performance, you can give more or less examples to the model. And generally the number of examples depends on the task complexity. And this is a method to teach the model more on how to generate Cypher queries based on natural language queries, but there are other methods, like for example to fine-tune the model to create Cypher queries, but you need far more annotated data to do so. Another method is to store far more examples of users' queries and their associated Cypher queries, and you have them like separately, and during inference you take the user query, you go to search to the most similar query to this query, and you return the associated Cypher query. So in our case, let's continue with our few-shot learning, but don't hesitate to let me know in the video comments if you need more details on the other approach that I've just mentioned. Here we give more information, like the categorical values of a few nodes properties, some other instructions like use abbreviations, use is null or is not null, never include group by, and so on. And at the end of the prompt, we inject the user question. So this way we defined our both prompts. Now we need to define our graph as well by connecting to the database instance that we created in the previous video. As you see here, we read the needed information from the .env file, and we read the model's information from the same file as well. Now we are all set for our Cypher chain, so it's time to give it a try. Let's try this question, which is, what is the average visit duration for emergency visits in North Carolina? We invoke the chain with this question and we print the result. So let's run this, and here we have our result. So as you see here, the model is, so as you see here, we are returning the chain execution steps, and at the end we have the final result with the average visit duration equals to almost 15 days. And this is great, guys, that we are returning the intermediate steps because we can check the query that has been generated. So that's what we can do here. So as you see, the query matches on visits at hospitals. This relation between visit and hospital, we have it in our database schema. We precise that the state name should be North Carolina, which is in our query. We precise that the admission type should be emergency, also precise in the query. We are calculating the duration between the admission date and the discharge date, and we are giving an alias to this variable, which is duration, and we average on the days of the duration, and we calling the result average visit duration days, and this is what we find in the final output here. Now let's try this query on our instance. Here is our instance that we created last time. Let's paste the query here and we run it, and here we have the result that the model returned. This is crazy, guys, isn't it? Like, we have the whole process done by the models. A model converts the user query, it converts it to a Cypher query. This is executed in our graph database. The results are returned. Another LLM takes the results and reformulates them for the user, and the final result is returned to the user. And again, we haven't even trained these models to generate Cypher queries. We only did few shot learning here. But here, guys, it's always a good practice to check the queries generated by your model and refine the model's prompt if necessary, because in more complicated queries, the model might generate non-valid queries or queries that they don't answer the user query. And in these cases, we apply the other two approach that I mentioned earlier. This is it, guys, for the Cypher chain. In the next video, I will talk about the vector chain, which will be used alongside with the Cypher chain by our chatbot. Thank you guys for watching. Don't forget to subscribe to the channel and don't hesitate to ask me questions if you have any.